So we're going to be talking about JavaScript promises today. Real quick survey. How many of you are kind of just beginning? This is an intro to promises for you. I kind of want to know if I should breeze over some stuff or if I should move on to more advanced things. So I caught just a few beginners. All right. I'll try not to leave you in the dust, but we'll maybe go a little quicker. All right. So JavaScript promises, they are the future. We were just talking about. There's kind of a joke in there because JavaScript promises used to be called features, but they're not promises. I'm Eischeid. I'm the lead developer at Debugging. We're in Iowa, where I live. I'm also a Spine.js maintainer and father. This is my littlest guy. I've got two other ones. You can find me on Twitter, where I occasionally tweet. Alright. Into the stuff. So first of all, I do not promise to get everything correct. Promises are kind of simple and complex. It's just the nature of them. They're trying to solve a very difficult problem to do concurrency and asynchronous code in a synchronous style and in a trustworthy manner. And it's hard. For me, it was kind of like wrapping my head around jQuery as a prototype language, right? I kept hearing that's what it is and get it explained, and I would be like, oh, I get it. And then something would come along, I guess I don't get it, you know? And that's happened with me with promises a few times as well. There's these gotchas and edge cases that can be tricky. We'll try to cover some of those. So concurrency is hard. In JavaScript, it can be as hard as anywhere, I suppose, because the event loop happens a bit unpredictably. I mean, it's predictable, but you don't always know when things are happening. And so if you've got task A and task B, and you want to wait for task A and task B, you want to know when they're done, so then you can move on to the next thing. You can assume that they're going to be done, in a certain order because they usually are, but it's not predictable. So, along come callbacks. Callbacks will let you solve this problem somewhat, but they kind of confuse inputs with outputs, right? So your purists will say, you're giving callbacks are bad for control flow. But they work, and we all kind of know how they work at this point if you're experienced with JavaScript. But there's some gotchas there. Can you trust callbacks? That's really the issue, and that's where promises are going to try to solve this. Can you trust that callback to call when you expect it? Can you trust it to call only the number of times you expect it to call? What if you're dealing with a credit card transaction or sending a billing receipt to somebody? This is placing a lot of trust in this. And can you trust it to let you know if there are errors? Can you trust that it's going to give you all the things that you needed in the right order, etc.? So promises are a specification to help deal with this. This is just the website for the spec. You can read this in 20 minutes, but it will probably take you a lot longer to understand it. And you could jump into the debates around how to interpret it, right? Because there are lots of implementations, which you can link to from here. And there are tests where you think, well, since there are tests, all the implementations should be the same, right? The tests are based a little bit on interpretation, and they can't cover every angle of interpretation. So, unfortunately, all the implementations are not the same. Some of them that are out there are Qjs, RSVP, there's asequence, there's just simple ES6 polyfills, processes as an ECMAScript 6 specification. But they all can have some issues, and some of them are around that trust thing. So, in summary, the purpose of a promise, we want to deal with concurrency, we want to express our code kind of synchronously without making it synchronous, because that works for our brains a little better, at least for mine. And we also want to do it in a way that's trustworthy. All right, so let's get into it. Promises have state. So we've got 4 states here. Although there's 2 states and then substates. So you have pending and settled. A promise is either pending or settled, meaning it's fulfilled or it hasn't. And once it's settled, it's either fulfilled or rejected. Only one, forever, and ever. That's the idea. So the state never changes. So once you're fulfilled, you're fulfilled. Once you're rejected, you're rejected. And you get fulfilled with a value, and you get rejected with a reason. So we'll talk more about that. And the idea is really that the state is trustworthy. This slide is just to help me get on the NSA watch list a little bit. But not all of promise implementations allow that state be kind of immutable. jQuery gets a bad rap because of that. jQuery has a promise implementation deferred and other things that, and they even use the word promise, that you're going to hear a lot of people talk about how jQuery promises aren't really promises because they're not trustworthy. All right, so here's an example, kind of a simplistic example of the old style of callback. We all know how this works, I think. You're sending a callback, you're expecting something asynchronous, we're going to load an image, and then maybe we want to do some processing with it. We'll come back to this kind of use case over the course of this. And then we have the promise style. It really doesn't add much if you look at it there, right? So maybe an extra line of code, an extra function call there, right? So it's not that much more complicated, but there's this new then function. And you have resolve and reject, and you're returning a promise. Okay, this is all there. That's not that much harder to write out, but why would you? Well, callbacks are relatively, you're almost never dealing with something quite so simple as this, right? So as soon as it gets more complicated, you end up doing what they call callback hell, or the pyramid of doom. If you're indenting your code, the callbacks are nested in callbacks, and then we've got to catch errors if there are errors, so you have try catches, and oh man, good luck debugging that, right? Pyramid of doom. You can avoid the pyramid of doom because with promises, it's much flatter, right? You go do this thing, then do that thing, then do that thing, get to catches and some other stuff as well. There is also, a lot of people are familiar with done. It's not part of the spec as of yet, but done is really a lot similar to then, so we're not going to cover it too much here. Alright, so then there are errors. Oh boy. Before I get to errors, let's look at a little more basic example. So then takes fulfill and reject. Remember, fulfill gets a value, reject gets a reason. That's just how I think about it. That helps me a lot. Reject and the reason should always be an error object. That's not enforced, but that's the kind of convention in the system. Most of the time, you're not going to be building up your own promises, and you can. We just showed you how to do that, but you're going to be getting a promise from something. You know, if you're in Ember, I believe Ember uses RSVP. I've got some Ember guys up here. You're going to get a promise from them. You know, if you're doing something with your model or whatever, and then you get to deal with it. Right? So Ember will, I think, or RSVP will hand you back errors, as your reason. At least that's the convention. All right, so that's how you structure it. Take your 2 calls, pass them on. There are 2 kinds of errors that will end up into that reject number. You get explicit rejections, and then all of that. So if you do an actual reject, another example. Not all my examples of my own writing, and just, this is one of the tutorials out there that is worth reading. This guy's doing an AJAX request, opening that and saying, okay, if we have a reject, well, we have a network error, we're going to reject it. That's an explicit rejection. You're taking the reject part of the promise and you're passing up. You will end up in the reject handler of the then. Also happens here if you have a non-network error, right? So you get a 500 back from the server, or 444, whatever it is. You can reject that and you can pass on the error. So it's passing the error object. So those are explicit rejections. But you could also have a thrown exception. Let's say you wanted to parse the JSON right here, or inside of the next then, right? As you're chaining, you want to parse some JSON. But it turns out not to be JSON. You got HTML back. So JSON.parse that thing throws an error. That will also fall through to the fill. I'll get to some examples of that. So that's all the rest. Now you do have to be a little careful. Let's show an example now. I'm paying attention to the top part yet, but errors can get swallowed, and so you notice here that I'm throwing an error. If I don't do that, then I'm essentially catching the error in that reject handler. And so if I don't throw it on, it's caught in the stack, and it's not going to keep going. The next one sees it as a success. Right? It's resolved now. And so you have to be careful with that. You can swallow errors and they just disappear. And this is a real big gotcha with promises. All right, so getting into the non-trivial use case, let's look at an advanced case. Again, I mostly listed this example because it was well done. Let's say we have an async thing, and we then want to do a few more async things, right? So you can see that this is a fairly flat structure. You can follow this with your brain and your eyes real easy. So async thing 1 goes to async thing 2, then async thing 3. Then notice there are no there are no reject handlers on those first 2 then objects. So what happens to errors in that? They fall through. They haven't been caught. But then we have a catch. So catch is the next. Catch is just sugar for them. It's kind of a shortcut way, but I like it a lot because if you go back to the async example, notice how the catch is at it's right on this edge. You don't have to count how many handlers did this then function have and figure out what it is, or that's catching an error versus not. And so I really like catch and recommend its use. Again though, it is just sugar for then with an undefined function. Forgot to mention that. So then the functions are both optional. It takes the 2 arguments, fulfill and reject, and both of them are optional. So if it's undefined, then it will do nothing. As you saw really with the advanced case, right? These don't have reject parameters because they're optional. They just pass through. And sometimes that's what you want. All right, so why would you do something like this? Let's think about our loading an image example that we were talking about before. So let's say that's async thing where we go and get the image, then we want to do some processing with the image. We want to scale it, or maybe we want to add a filter, and it fails. Maybe it's a PNG and not a JPEG or something. Whatever, so we can have an async recovery. Okay, if we recover, great, move on. If not, try recovery again, catch the errors, right? So we're moving from async thing 2 to async thing 3, and they both pass to async recovery. The green arrows here are the happy path, that is. And the red arrows are the error cases, either an explicit rejection or a thrown exception. And so if you end up at async thing 4, then you have another exception. Look, it kind of hijacks my keyboard shortcuts a little bit. There we go. Async thing, this lines 9 through 13, that has the 2 functions. So it has the fulfill and the reject. Recovery's in there. Catch it one more time. Okay, you know what? We just can't process this image, and we don't have to worry about it. And then we have one more then. How would you do that one more then? Well, let's say you want to put up a spinner while you're doing all this work, right? You want to show them that we're thinking about it, we're working on it. But at the end, you want to, if everything failed and we caught that error, turns out there's nothing we can do. We still want to take the spinner down. We don't want to let them think that, hey, we're still working on it. There's still hope. There is no hope. It's all done. And we want to take away the spinner. In this simplistic example, right? Yeah.
For example, the callbacks you have of them, you return something to, then read the cache. If it's successful, you just fall through the next step. Next up, that it says that you see read the cache right after it, another event. So if it's successful for async.
Yeah, if async, if 1 through 3 are all successful, it falls right through that catch because they're passing a resolve, which is undefined in that catch function essentially, right? Catch does not deal with resolve. It falls right on through, and it falls right on through the next event exactly. And we'll go to async 4, which is
so in that next event, you got your 2 functions there, so you actually split out. You did it that way instead of catch because
just to show the
difference.
Yeah.
Okay.
It can be important though, because you remember that only one of those gets called, versus if you kind of want to chain it and always make sure that something's getting called, you can put it onto the next thing. There's another important aspect of then and promises in general is that then always returns another promise, right? You're taking a promise and you're working with it, and then you're returning another promise. You're passing a new promise on to the next event, so that you can continue the chain. So that's actually an important thing to lock away. Then always returns another promise. So yeah, that was, you were saying, what happens if all those pass with you in the happy path? You just fell right through to async thing 4. And async thing 4 had the 2 handlers, right? It had a success and a resolve and a failure. And if everything's good, then just hide the spinner, whatever you know. All right, moving quick. So, this one is a super handy dandy wrapper for promises. It's a bit like Inception, but not. Okay. Let's look at an example. It's really simple to use. If you're familiar with jQuery 1, then you will kind of know how this works. It's a method or the static method on the promise object itself. So you just promise that all, and you give it an array of promises. So let's say you built up a whole series of AJAX requests. So in our real world use case, I'll often use this. We're going to have our single page web app, or maybe it's an Angular web app. We use Spawn.js, but you have to say, well, is this user authorized to use this app? Is this user? Who is this user? What is their role, etc. And then I need a handful of data before I'm going to start rendering my views and going off and getting the rest of the data that I need, depending on who they are, right? So I have a whole array of of things to do before I'm going to do the next thing. But I want to make sure all of those steps complete before I go on. Now you could do this with callbacks. You can put a bunch of flags and whatnot to say, is this one done? You can set it in an interval and say, okay, everything's done, everything's good. You're having a spinner, loading the page, etc. And even a progress bar as the flag's complete, maybe. But promises are just a much simpler way of modeling that. So give it all your things, and then when it's done, you get an array of results in the same order as the array of promises that it was handed, and you can move on from there. It also accepts a reject function. It's the first rejection value, and you will get it as soon as any one of the promises in the array rejects. So that's important. It's kind of, okay, this whole set of promises is shot. Here you go. This is the error you need to worry about. There is also a race function. I'm not going to cover that one. I'm not as convinced of the usefulness of race, but it is there. It's kind of a whatever finishes first. I'll give it to you scenario. And again, this is very synonymous with jQuery's when, which you may be familiar with. Then you have a couple more static methods. These are kind of shortcuts for when and promise constructors, essentially. I have an example of this. So here's a JS build here. We've got, it's very hard to read the screen. I don't know how many pixels that I did when I was setting this up. Promise one, we're just going to say promise resolve this. Now this is essentially promise, this is return a new promise, and then the first thing that happens in the new promise in the constructor is a resolve call. Right? It's just a shortcut for that. So you don't have to type out function, resolve. And reject is the same situation. Just the first call is reject instead of resolve. Now this is where you would practically use this a lot of times, is if you want to take something and make it a promise. So if you want to take a jQuery promise-like thing and turn it into a true ECMAScript 6 promise, you would pass that AJAX in as the argument to resolve, and now you have a true JavaScript promise that should not change along with that. Alright, so here's a live example, and if this runs, and you can see what's happening here a little bit. So we go ahead and resolve with this string or JSON, and then we're going to parse that string, and if we didn't get a string, we would get an error. Move on. We're going to put that string in the DOM, and that's what shows up right there. So promise thing one immediately resolves, and promise thing two immediately rejects. Now let's see what would happen if I made this not good JSON just for fun. Right. We have errors. Now we have two loopses. So I just followed a different path, right? So I tried to get to this JSON parse, failed there. So it fell through, and it fell through down here to the fail function on the next. But I returned or threw an error, so the next promise goes to the reject, and we put out loops. Take that out. Notice what we're doing here. Well, throwing away, I mentioned this before. This is a good idea if you want to make sure that things aren't swallowed. If you're handling it and you don't care about that error, or you're going to do something else, that's fine. If you want to move it down the stack and you want to actually print out loops, then you better throw this. If you don't throw this, where'd it go? It's totally lost, and this you can be hunting these down for a long time. So be careful. Make sure to use your catches. Make sure to use your reject functions, because they just disappear. Now, the nice thing is that if you actually are throwing errors and catching errors, you get a lot of stack trace in your debugger, and this can be really a lot better than your callback stuff, because you weren't sure what you were getting back from the callback. Is it a man or is it not? So you're not always sure what to do with it. You know, detect if it's an error, if it's a function, if it's a whatever. All right. Then again, so then can be called multiple times. Remember the state of a promise, once it's settled, it's settled. Once it's fulfilled, it's fulfilled. It's rejected, it's rejected. It doesn't change. So this is a list example as well. Look down at the bottom, we have promise thing 1 and promise thing 2 again, right? So I'm going to clear the console here. So I'm working with limited pixels. We'll just hide the output for now. So we see that this is a little unpredictable. When we're dealing with promises and call them again. So we've got promise thing 1 done happening up there. We've got promise thing 1 done happening down here. Well, it looks like that one gets called first. Why does it get called first? I actually don't know. It's a little bit unpredictable at times. I noticed when I put this same code over in Chrome, this is Firefox, when I put the same code in Chrome, I get a different order of stuff out. And it usually is like, so if promise thing 1 is listed before, so this then would print to the console before that then. But this then, which is count, may be before that one, or maybe be after that one. The second error may be up before the then again in the console. It's a little unpredictable with that, how that happens. I don't know if that's just a difference in implementation in the browsers or what that is. It's just my experience, so it's something to watch out for. But the then does get called with the same object, you notice, right? It's because it's working on the same promise. That promise is solid. You can call the then with that same value. But if you went farther down in the chain, remember, every then is passing back a new promise. So we don't actually keep track of all of them. They're not set to variables so that we can call then again on them. So it can change the stack. Even the stack of promises that you're dealing with, they might change. Some of them may, depending on how you build the code. But each promise keeps its state. What is this? This is always a tricky thing of keeping track of this. I'm always constantly logging out this and trying to figure out what is it. The problem, or I wouldn't say it's a problem, the thing with promises is that this is supposed to be undefined. So if you're in strict mode, this will be undefined. It's not a thing. If you're not in sloppy mode, I guess, then it will be the global object. So it's just a window, window whatever. If you want to see this happen, you could do that real quick. It would be, let's go log. Apparently JSPM is going to be in sloppy mode, just so you know. This. And it's the window object. Okay. So what does that mean? If you want something to get past them from your promise, you got to deal with Scoping. You got to know what maybe you do the this is that trick, right? If say you're in some view controller, frameworks controller, and you want the context, you want that controller. What you're doing there, var control equals this, right? And you then can access control within the promise as you're handling it there. Or if you're a CoffeeScript fan, I tend to use CoffeeScript, then you got the double arrow function This can be a little tricky. It's just setting this to underscore this and some stuff like that. It's just a shortcut for a lot of the same stuff. Basic variable scoping applies. All right, so as everything roses, promises, so great, right? Everything we've seen. You got any questions, first of all? Try to handle a few. Yeah.
Is that you bind the function?
Yeah, you can. You can say bind. So if you wanted to say then, you do it right here, right? Bind my context, right? Whatever it was. Or, I don't know if you would want to bind this, right? I guess you could. No, I just don't do that very often. So does anybody else have experience with doing bind? You can do that? And then you can still chain off it with the next then?
So you wouldn't do it like that though, I don't think. It would have to be inside the parentheses there. But
also you would put that kind of right?
Yeah.
Sure.
That works. And you can bind to this. Like in this context, this is the window. But like,
right, that's where we would see it. But
if you're inside of something, or this is bound to something else.
Yeah,
actually, then you need a couple lines left too. Let's hear.
You got to bind it in both places.
Yeah, you want to do wherever you're going to use this.
Right. So you would want it in both of those spots.
Personally, though, I would just do like bind that equals this.
Yeah, that's what I do. Like all the time. I don't really use bind too often. So. Is bind standard now? Like,
I'm not sure what browser supported.
It doesn't work on E.
Doesn't work on E?
I don't think JavaScript works in E.
That's an issue sometimes.
It's the right nice supported.
So it's an option, but maybe with caveats, right? So be careful with that, with binding. So implementations abound for promises. If we're talking about what browsers support promises today, obviously I'm in Firefox. Chrome also supports it. These are both shipped. We talked. Maybe there's a few edge cases where they differ ever so slightly around how gangs are handled in the stack, but they're working. And I believe Node.js, some of the beta versions they have it, because basically Node.js uses the engine from Chrome. So it's there, but if you're going to be using this in the real world, maybe you're worried about IE is, it's coming. They're working on it. This is, it says in development. Right? This is their web page for it. So I don't know what that means. I don't know if IE 12, but it's good. Right? They're working on it. In the meantime, they'll have to use a polyfill. Right. Now we talked about promises are great. Should you always be using promises? No. Let's talk about some cases where you wouldn't use promises. On this little example here I built for telling me when, what's the price of Bitcoin currently? Bitcoin's fine. Alright, so we run that. Bitcoin is, oops, I got it. What do I do here? Oh, this console value had a bunch of stuff. Bitcoin is $507 right now. This is how we did this. So Firebase is kind of an online database thing that was born from here. Firebase provides some APIs for checking when things happen. They'll notify you. So this is an event system, right? And I'm using Firebase on here, which is actually, I meant to show you once. So I'm going to go, and next time that Firebase gets an update on a Bitcoin price, they're going to let me know. And that's going to happen asynchronously, so I can wrap that in a promise. But do I need to wrap that in a promise? The answer is no. I don't need to. There's no reason to make this do this. But it's fine, so we can do that. What can get weird is if that event runs only fires once, obviously. And so that makes sense. try multiple times. But I want to let that in a promise. What happens in that case? Anybody know?
Once the promise is settled, it's settled.
It's settled and settled. So then this new thing comes, and then it tries to reject, or it tries to fulfill it. You might expect it to, because you wrote your code. I'm expecting this to happen. Nothing else happens. It never changes. Why is my Bitcoin price updating? It's weird. So this would be a bad use for promises. Events are still a good thing. So if you're dealing with click handlers, if you're wanting to check if this page scroll has changed, or the window size, or whatever, these things that happen multiple times, use events, don't use promises. All right. Show you an example of it fail. Okay, there's a fail. Or if, in this case, the object is undefined and it throws an error, right? It tries to reference a property on the undefined thing, throws an error, but then we have a next node. Or in this case, actually, maybe it's a little hard to. The next node does have a catch that throws in the question marks. We didn't have that. We didn't. Was Bitcoin a thing anymore? Has it disappeared? I don't know. Also, callbacks are not evil. Some people really don't like them, but they can be more efficient in some cases, right? So a promise always returns another promise. So but if you're not using it, then you're creating promise objects for nothing. And callbacks don't have that problem. So you could say that callbacks are more efficient. Sometimes they're just simpler. Some it's fine. So I wouldn't throw anybody out with the bathwater. I still use callbacks here and there. And in Node.js, I don't have a lot of experience using promises in Node.js, but I know there are some specific polyfills for that one, and should be working since this version, which I also haven't used. So, all right. So, do you have any jQuery promise haters? Some people are very passionate about this. I found as I was researching this talk. Yeah, we got a couple. How would you summarize why you think jQuery promises are bad?
It doesn't picture any good promise.
Right. So with them, you can't chain it, right?
Once you create a new promise within .NET,
you have to explicitly do that, and that's a real problem.
It's not you're expecting it to work a lot of promise standards.
Right. Yeah.
If you're okay with the main purpose, then it's you're writing the expectation of how it should be.
Practically, for me, most of the time, if I'm using jQuery, I'm just like, okay, this AJAX call is done and done. I use done in jQuery land, and that's fine. You have a done and a fail, and I'm not really, and then I'll move on and do whatever I want to do with it. So, practically speaking, I understand the argument for why jQuery promises are bad, but like you said, it's mostly about what you're expecting.
They're not necessarily bad, it's just they don't have the steps, I guess.
Right. And they're not A+ compliant. Are they A- compliant? I don't know. And I think the reason for that was that they implemented early. Right? There was an early spec, and they said, okay, we'll put that in. And then people started using it. I can't break it.
It's easy to use.
Yeah. And I believe if you're using Backbone, a lot of the promises they just hand you jQuery promises, right? So one of the things I see a lot of Backbone projects do is wrap this right away, right? Anything that's a jQuery promise just is now whatever promise libraries I'm using promise. So you can just move on. And so that's what this little bit of code says. Well, whatever promise thing you think is a promise, now it's a promise. We'll treat it this way. So if you hate jQuery or just want it to behave consistent with promises. That's a good line, good step to use. All right. So this covers most of what I had, actually. And so these additional resources are actually really useful if you want to dig in deep. So one of the things I thought about doing with this talk originally was kind of building a promise spec and let's do this live. I ran that by some coworkers of mine, and it was like, no, it wasn't a good idea. Spec is complicated. I think it can be helpful, but honestly, it works just as well to treat promises like, I need to know how it works most of the time, not what's happening under the hood. I can kind of treat that as a black box. There are these very few edge cases, I would say now, where you want to know why is it doing that. But you can go read the specs. There's all these implementations like open source that you can go read. And there's this link, the daily.js one, promises in detail. That's essentially what they do in that article. They kind of build up a spec, and they're going to talk you through. Okay, here's what the then function might look like inside of a promise thing, and all these slides and code samples I showed should be available. I think we're doing a GitHub repo for all the talks, and so we'll be able to click on these. So some people taking pictures and stuff. So that one's the process in detail. That one's worth checking out for if you want to dig deep into what the specs kind of look like under the hood, but in a build-up kind of way. Right? You don't want to just go to RSVP.js and start reading the code because it can be overwhelming. This will kind of let's build a run, let's build a all, let's see what they might behave like. Promises the Getify blog, he talks about the trust issues with promises, and so there's some really good stuff there around the state and how some of the implementations may not treat that with as much respect as he thinks they ought to. And practically that can be important. That if you were talking about credit card transactions or things that I really need to trust this, that's not code I normally deal with is having to do that. So I'm a little less concerned about the trust and more about the extendability of promises. I showed you the ECMAScript 6 tutorial element. This is the article. Let's go through some stuff. It ends up talking about generators. Let's see, generators and all the rest. I think it's down here. It's kind of a long article, but you get generators and yields and these things, and promises with that can be incredibly powerful. I don't think we have time to go into that here, but I think there are some other talks that will cover that. So if you're interested, check those out. Then we've got a bunch more examples and things, especially Node.js stuff on promises.org, and your handy-dandy can I use blog, which will tell you the latest matrix on browser support. But for a lot of what I do, we're talking mobile. By this now, when iOS 8 comes out, and when Chrome and Firefox have shipped on Android, these things, we already have promises. I don't have to polyfill anymore, so this is great. That's all I got. Let's see. Any more questions or discussion? I think this is a great time for that.
So what do you see happening to like the current job current promises like you and Uber? Are they just the higher they offer things in addition to?
They do. They tend to extend the specifications. So a lot of them will use the done function or some other things. I have tended to stick real close to the strict polyfills. So I'm not an expert on those things. Where I am a little concerned about it at times is that they kind of extend the spec, and then people will take them. They tend to namespace their promises. It's like a q.promise or rcp.promise. And so they namespace it, but then what I see people doing is saying, well, promise is this. They throw it on there right in their code, and that's going to be a problem. We've got to watch out for that. If you ever inherit code and you see people doing that, and like look for odd behavior as the browsers update, right? And if they ever implement done, and now we've got conflicts and issues. That's a good question. Yeah, I'll repeat the question. So, how do you unit test promises? Carefully. I actually have a talk tomorrow on using Jasmine, and so that's where my tendency is to the functions that the promise ends up calling. I spy on them, and that's a Jasmine specific thing. And you see, well, okay, I'm just expecting that to get called, and in jQuery, you can just call resolve on things, which you can't really do. Just ECMAScript 6 promises, you have to kind of let them resolve themselves. But in jQuery, you can say, I'm going to take this and I'm just going to take that promise thing and I'm going to call resolve on it, and then it'll be done. And then you can look for that thing inside of your then handlers or whatever, fire off. So that's one of the ways I'll do it often. I don't know if I'm answering your question. What's that? Mocha
passes a function that you can call your function. So that your unit test waits for the promise to be run.
Right. So it waits for an async code. Jasmine does that as well. And Jasmine 2 has moved to using a done thing. It's kind of got its own way of dealing with async. I think all of the testing libraries have something that tries to deal with async code. And that's essentially what you're going to have to deal with. Wait for this.
Jasmine must be new. That's why you chose one in the first place.
Right, Jasmine initially it's the way that it would try to do async is under the hood was just interval loops and just I'm gonna wait for a while and check this condition and see if it's true. I don't know how Mocha does it. I kind of inherited a lot of Jasmine stuff, and so I looked at Mocha too. Any other questions? All right. Well, thanks for coming, guys.